distribution system. And I have, during the first class, I have shown you these diagrams, how the distribution takes place, what is primary transmission, which level is transmission out of those transmission distribution, which is the primary distribution, and which is the secondary distribution. Okay. So we will start from there. Now, I think already I have told you what do you mean by feeder and distributors. Okay. So these terms will be using these terms again and again in this chapter, and to calculate the different voltages and currents in the system. Okay. So as you can see, let us say this A stands for a substation. Okay. From the substation to the distribution. Okay. So I can say SC or SA. This is called feeder. Now in feeder, you will see there is no tapping. Okay. Now these feeders are going to supply the distributors. So which are the distributors? The term AB, AD, CD, and BC. These are distributors. There you can see the tappings are done to supply different consumers, maybe domestic or commercial. Okay. So I can say feeder is according a conductor which connects the substation to the distribution, and generally there is no tappings in the feeder. Okay, that is the difference, because sometimes it is asked what is the difference between a feeder and a distributor. What is the difference between servicemen? Servicemen, as I have told, it is the last conductor which connects the supply system to your house. Okay, if you talk about your house, generally a black wire is there which is having two conductors. For single phase I am talking about. So service wires are those conductors which connects your meter to the supply system or the conductors on the pole. Okay. Now these are the definitions. So already we have discussed. I'm just skipping this one. And this also I have told you that any distribution system, these are the minimum requirements. Okay. Continuity, constant voltage, efficiency should be high, safe for consumer point of view. Okay. Layout should not affect the appearance of the locality, that we also I have discussed. Okay, now in India generally we don't follow that one, but obviously in future we are going to look for that one also. That the appearance of the locality should not be bad. Your conductor should not be, or you just create a junction box. Let us say you are going to connect 10 consumers, so you create a junction box from there, and then from the junction box you connect. Don't connect all the conductors from each of the house to the pole, so that look doesn't seem to be good, and lines should not be overloaded. So as you can see, day by day the loads are increasing, plus the number of consumers are also increasing. Different appliances which are used for different purposes are also new appliances are coming up. Okay, so in the view of easing out our life, we can say the demand for electricity is going to increase. Okay, so now let us say in 10 years back, your total demand at your house may be 1 kilowatt or 2 kilowatt. Okay, if you see, maybe maximum 2 kilowatt was there. I am talking about my point of view also. Before 10 years back, maybe the demand was 2 kilowatt around. Okay, one AC is the load which is the maximum load of 1.5 ton. Otherwise, all other loads are very small. LEDs, balls, all those TV, all those loads are very small. Okay, but now the same load has gone up to maybe double, 4 kilowatt or like that. So when I have increased the load or the demand of the consumers and increasing, now the lines may not be changed, because it is a huge investment from the point of view. Okay, so what you have to do when you are designing the conductors for these feeders and distributors, you have to keep in mind the future prediction of, let us say, 10 or 20 years or 50 years, like that. Not 50 years, maybe 10 or 20 years. Okay, so and even if that is done, generally, if let us say your prediction that in 20 years the load will be 5 times, then you may not be able to use the conductors of 5 times of the requirement of the current requirement, because the cost will be very high. And if you are having high cross-sectional area conductors, that also increase the losses. Okay, so what you have to do, maybe you have to go for parallel lines, like double circuit or multiple circuit lines. Okay, or like in our college, and as the new block has come up behind our electrical department, you have seen there is a new block where the mechanical department has shifted. So now the demand has increased by a lot. Even few years back, that textile department and chemistry department block was not there at all. Okay, so as the demand has increased, now instead of a 11 kV supply, we have demanded, or we have gone for a 33 kV line. Soon there will be a 33 kV underground cable connected to our college. So like that, we have to take care of the overload, the demand increase in the load, and therefore, and we have to see that the lines are not overloaded. Now, the distribution system, generally it is done according to the type of either it is AC or DC. Generally, DC distribution systems are not there. The only drawback is we cannot increase or decrease the voltage as per our requirement. If that can be done in any method, because now solid state devices have come up. Solid state device means those thyristors, GTOs, BJTs, IGBTs, which are performing very well at high voltage also. Then we will be using DC more. What is the advantage? Now DC, there is the drop is less. Okay, and the number of conductors are also less. So DC has its own advantage, but only disadvantage is we are not able to step it or step down it according to our requirement. And therefore, till now, all the equipments or all the transmission and distribution is done in AC. But still, I think all of you have seen there is now a DC transmission has also come up. Okay. Then, according to the construction, or whether it is a overhead transmission system or underground system. Now, overhead systems throughout India, you will see most 99% are overhead systems. Okay, maybe up to 99.9 also. Now, that was done because that when we are going to think about the supply and distribution system, now it is a huge investment. And initially, the target of India was how to connect or how to reach all the cover up all the geographical area of the country. Okay, not about the economical aspect of that, or not about the future safety of that. But now in Odisha, as you can see, regularly we have cyclones. So now I think all of you have seen underground cables are underground cable work is going on in Bhubaneswar. So like that, slowly we may go to that one. But the underground cable system, if you compare with the overhead system, maybe it is 10 to 100 times more costlier than that one. Okay, so generally the first preference in India is overhead system, and then if you have, as I have told, now we will be getting a 33 kV underground system to our college. So maybe you will be able to see how that underground cable is going to come. Okay, then the scheme of connection. There are different schemes of connection. Means there is a radial system, ring system, and interconnected system. Now we will go to that again. What do you mean by radial system, ring system, and interconnected system? Now already I have told you what is primary and secondary distribution in that previous diagram. The part of the electrical supply system between the distribution substation and the distribution transformer is called as the primary system, or primary distribution system. Whereas the secondary distribution is from the distribution transformer to the consumer. Okay. So basically, this is the primary distribution system. As you can see, it is a 3-line system, 3-phase 3-wire system. So you can see there is a substation. For example, it is 33 by 11 kV substation. So some of the consumers directly get 11 kV. Okay. Like the college, our college supply is also 11 kV. So it may be assumed to be a big consumer. Similarly, if you have huge apartments, those are also getting the supply at 11 kV. Otherwise, maybe if the load is more than 5 kilowatt, the domestic supply gets a 3-phase supply. Otherwise, it is a single phase supply. Okay. So this is all about up to this distribution transformer. It is the up to the distribution transformer. It is the primary distribution, and then from this distribution transformer, we generate that 4th conductor, which is the neutral. Okay. So in secondary distribution system, we have that 4-line system or 4-wire system where the neutral is also taken from the distribution transformer. So you can see up to this distribution transformer, it is a three-wire system transmission or distribution. From the generating station up to that point, it is a three-wire system. Okay, only at the distribution level or distribution transformer only we generate the neutral. So sometimes it is asked where the neutral is actually going to originate in a supply system. So it is at the distribution transformer where the secondary side generally it is having the star connection where we are going to generate the neutral. And depending on what is the requirement of voltage, maybe as I have told, if it is more than 5 kilowatt, we go for three phase. Otherwise, it is a single phase, and for three phase it is 400 volt, and single phase it is 230 volt. Okay. So let us see. Going to other slide. Now these are different DC distributions or AC distribution systems that we will also discuss in the coming classes. I'm just going to have a discussion about the DC distribution system. Okay. Now, DC distribution system generally, or if you will see, then in not so much used in our country, but some of the European countries or Western countries are using this type of distribution system because of their advantage that it is having less loss. The capacitor and inductive effects are not felt, okay, or not there. So it is having always, depending on the demand of the load, you can generate the power easily without thinking about the capacitance and inductive effect. Okay. Now there are few different types of distribution system in DC. One is the DC three-wire system. Okay. So I am just going to. Now these are the different DC distribution system, as in you can see in the first figure. Now, as I have told, the main drawback of DC distribution system is we are not able to step it up or step it down. Okay. So now, as I have told, in AC, if the demand of the consumer is more than 5 kilowatt, we are going for three-phase line. Why? Because phase to phase, so line to line voltage is 400, so that you will be able to draw high amount of power. And for small loads or small consumers which are below 5 kilowatt, we are going for single phase. So 230 is sufficient to handle that up to 5 kilowatt load. Now in DC, we cannot do that. Okay. So what we do, we instead of taking two line system, we get three line system. Okay. So in three line system, as you can see, two generators are there. The middle point of the generator is taken to be neutral or the neutral line. And as you can see, generator one, this is the first or across the load one, L1, the voltage is V1, and across the load 2, the voltage is maybe V1, V2, like that. Okay. Now, if you have a very heavy load, directly you can take a connection from these two where the voltage available is 2 volt. So you may say this is 110 volt, this is 110 volt. So if you have very large loads, you can run it at 220 kV or 220 volts also. Okay, so that is the advantage of having a two generator method or three wire system. Now here the difficulty is we have to have two generators running simultaneously, which will be costly. Okay, so instead of going to buy two generator method, we go to a single generator method, which is having, here you can see it consists of standard two-wire machine. So this generator, the same generator is having a two-wire machine, and there is a tapping at the middle. So let us say there are 1000 conductors in the armature. So for 500 conductors, we will take one tapping, and for another 500 connections, we will be taking another tapping. Okay, so that we will be generating three lines out of. General DC generators will be having two lines, but here, as there is a center tap at the armature, you will be generating three voltages. So if I will take the total armature voltage as 2V, at the center it will be, or across any 500 conductors it will be V. So you are generating the same effect of two generators using a single generator. So if I will take the voltage from a center tap and at the one of the end, then it is volt. It is V. Then if I will take across the total winding, it will be 2V. So like that, we are able to generate two voltages simultaneously. Now here also there is a disadvantage that if you don't have any balance load, because generally loads are depending on the consumer characteristics. So if you don't have a balance load, this neutral wire or the return path will carry that difference of current. Here also it will carry that difference of current. Okay. Now here, due to that, what happens, the voltage drop due to the difference in current, the current will flow in these windings, the voltage will not, may not be exactly equal to V and V on both the side. So to do that, we use a balancer circuit like this. Okay, so this is a 3-wire system where it is called 3-wire balancer set. Balancer set means automatically the voltage. Now in AC we have a balance. How we are going to have a balancing of voltage or stabilizing the voltage? You are using stabilizers, and stabilizers are nothing but automatic transformers. Okay, but in DC we cannot have that effect. The transformers will not work on DC. So how to stabilize the voltage? So this is one of the method of stabilizing the voltage. So it is a 3-phase balancing system. Here these another two DC motors or generators, you can say, depending on the use. 2 DC machines are there which is having a common coupling, so that both of them will be rotating in the at the same speed, and they are interconnected. Now and just summarized here somewhere. Here. So when it is the system is balanced, the current is I1 minus I2. Okay. So sorry, when the system is balanced, there will be I1 is equal to I2, so no current will flow through this neutral wire. But when it is unbalanced, as you can see, a current I1 minus I2 will flow, so that will change the potential. Generally, what is the use of this neutral? Neutral somehow is your zero voltage point. Okay, so if you are having a current in that, so your neutral may not be at zero. This is a common question, that what is the difference between neutral and earth? Earth always remains at 0 volt, but neutral may or may not be. Okay, so depending on, if it is a balanced load, then only the neutral will be at 0 volt. For an unbalanced system, the neutral will not be at 0 volt. So if you have a computer system or if you have a delicate appliances, generally earthing is required. You cannot depend on the neutral only, because neutral may not be at 0 volt. Okay, so in this method, as the potential difference is there, we are using this balancer system. Here you can see 2 small DC machines are connected across the line in series, which are mechanically coupled to the common shaft, and these 2 machines are called as balancers. Okay, now when the machine is balanced, these machines works as DC motors, and they are very small machines, so obviously there is a loss due to the motoring action of that. But when it is not in balance, out of balance, machine connected lightly loaded side will act as a motor, whereas the machine connected to the heavily loaded side acts as a generator. Okay, so let us say on the upper half the load is less. So load is less means what? This will be having less current drawn from the system. So if this is a less current drawn from the system, the current on this side will be high, so neutral will have a current. So what we need to do, we have to increase the current demand from the lightly loaded side, we have to decrease the current demand from the heavily loaded side. So for that, this particular machine, which is lightly loaded, will behave as if it is a motor, so that it will increase or it will draw more amount of current from the system. Okay, so I can say the load current increases due to the motoring action of this one, whereas the machine on the other side will be behaving as if it is generator. So as it is generator, it will partially meet the demand of the load. So if it will meet the demand of the load partially, the demand from the supply side will be less. So the current I1 from, what is the current here? This is the total, let us say this is I1, this is I2, so this will be I1 minus I2. This is not about the current in here. Okay, so if some part of the load demand made by the DC generator, which is in the generator, then the demand from the
so your screen is not visible.
Which one? The circuit?
The one you are sharing.
Okay, look. Is it visible? This one is visible or not?
No, sir. So let me rejoin again. I think I have some issues.
No, sir, the screen is not visible.
Share hitla kore gotti gala. Okay. Kohu na mate gotte minute. କେତେବେଳୁ କଟିଲାଣି
सर से बैलेंसर सर्किट टा अधा डिस्कस करथिले
Now it is visible, I think.
Yes, sir.
Okay. So balancer circuit DC machine main, what is the use that we are not able to use voltage stabilizers in DC, because all the voltage stabilizers use the concept of transformers. Okay. So if you are not able to use the transformer action in DC, the other option is using the balancer circuit. The balancer circuit is nothing but this is a combination of two small DC machines. Okay. So as you can see, this is the G is the original generator, which is need to be supplying to the total demand of the load. DC generator. These are two small machines which are mechanically coupled to a common shaft. So that means they will rotate at the same speed. Now, when the load is balanced, so what will happen? The I1 current will flow here, like the previous slide I have shown. So I1 current will flow here. Here also I1 current will flow. So neutral will have a current of 0. But when it is unbalanced, this will be carrying a current I1, this will be carrying a current I2. So current in the neutral will not be 0. It will be I2 minus I1 or I1 minus 2, depending on which one is higher. So neutral will not be at 0 potential. Okay. So to balance that, now, what is the advantage of that? If you don't have current in the neutral line, obviously in the loss in that conductor is 0. Okay. And when you have current in this one, let us say you are having a supply system, few loads are connected to this system and few loads are connected to this system. So what will happen? They will have unequal distribution of voltage across that. So always in three-phase AC also, always we try to balance the system. Try to, because we don't have a control on the consumer side. How many consumers or how many much load the consumer will use at a particular instant, generally we don't have a control on that. But we try to balance that system by distributing the total load equally into three phases. Okay, so let us say the total demand is 20 kilowatt. So I will try to give 6.6 or 6, 6 and 7 like that, or 6, 7, 7 like that into three systems, so that the imbalance current is kept minimum. So here our objective is to minimize this current in the neutral conductors. So how that is done? Using this balancer circuit. So this balancer circuit, when the load is balanced, these two DC extra DC machines will act as motors. Now you may say that this is going to consume some power, obviously, but most of the time the system is unbalanced. So the balancers are required to run according to the requirement what they are intended to do. Okay. So when it is out of balance, obviously out of balance means what? One of the side is having heavy load, another side is having lightly load. Correct. That's why the one side will draw current I1, other side will draw current I2. Let us consider that I1 is greater than I2. Okay. So the neutral have a current of I1 minus I2. So in that case, whichever side is heavily loaded, let us say I am saying that upper one is heavily loaded. So heavily loaded means it is going to generate more power, demand more power. Okay. So more power demand means it will draw more current. But at the same time, this balancer circuit, this generator motor will behave as if it is a generator. So if it will act as a generator, let us say total demand of the load, some of that is made by this generator action. So the demand from the distributor end will slightly decrease. So I can decrease the current in the heavily loaded side. Whereas the which is on the lightly loaded side, this particular machine will behave as if it is a motor. So if it is acting as a motor, the load on that lightly loaded side will slightly increase. Okay. So if it will increase, again the current will, demand will increase. So the balancer, what they do, in the heavily loaded side, this becomes a generating action. So the current it try to decrease. On the lightly loaded side, it becomes a motoring action. So the current demand increases. Now, so that will have what will do that? What will happen to that one? So the current on the heavily loaded side, as it is in generating, will fall, and simultaneously the current demand from the lightly loaded side will increase. So if you do that, the gap I1 minus I2 will decrease. And if you do that correctly, or the demand, the difference is not much between the I1 and I2, then these two will be able to equalize the current. So the neutral current becomes 0. So that is the use of balancer circuit in a DC three-wire system. Okay. So energy is transferred from lightly loaded side to heavily loaded side, as machine, as motor drives the machine as generator, because as they are coupled to each other. So if this is motor and this is generator, what will happen? The power will be motor will take the power and generator will generate the power. So that means it will take the power from the lightly loaded side and will take the power from this side and give the power to the other side. So they automatically try to balance each other in this run. Okay. So now due to the balancing action, the current in the neutral will remain 0.
Sir, sir, ଯେତେବେଳେ balance ରେ ଅଛି ସେତେବେଳେ ଦୁଇଟା ଯାକ ପୁଣି DC motor କାହିଁକି add କରିବେ?
Now when they are in the balancing mode, generally what will happen, the current is flowing from generator to the load. Okay, so which one is the higher voltage side? So this will be at the higher potential side compared to neutral. So they will behave as if they are motors. They are not round, there is no prime mover to them. Okay, who will inject the power? The prime mover will inject the power. But both of them, the terminal voltage is higher compared to the neutral voltage. So both of them will act only as the motor. Now, when they are in the unbalanced mode, what will happen? One of the machine will be running as the generator, the other one will be running as the motor. Okay, so there is we can say this the potential, and when the mismatch of current is there, you can see this potential will be, let us say this upper one is drawing higher current. So this potential will be less compared to the potential at this point, because it is going to draw less amount of current, voltage drop will be less. Okay, so now there is a mismatch of voltage at these two terminals of the generator. So and the system is made like that whichever side is lightly loaded, the voltage that will be acting as a motor. So if this system or this side of the distribution system is lightly loaded, demand of the consumer is less, it is going to increase their demand by moving in the motoring load. Okay, and as it is in the motoring mode, it is connected to the other generator by shaft. Obviously, this acts as a prime mover for the other one, and it becomes a generator. And due to the generating action, it is going to inject some of the power demand from the load, which is heavily loaded, and the demand from the grid side or from the main generator is decreased. Clear? So, but when it is lightly loaded, when it is balanced, there is no prime mover. Both of them are operating at the same speed, and both of them are subjected to the same potential. So they cannot run as generators. Okay.
Yes, sir.
Now coming to different types of distribution system. Basically, these are how we are going to connect the conductors in a particular area. Okay. So first of them is radial distribution system. Radial distribution system, you can say one-way distribution. That means the feeder is going to come from one side, and you are going to connect loads in one other side, and you, depending on the demand, you go on increasing on the load on the other side. So here you can see, let us say this is the substation. So the feeder is coming from the substation to the distribution end, and the distribution end you are going to connect more and more loads. Okay. So only one single path is connected between each distributor and the substation is called a radial distribution. Okay. So as you can see, it is a single conductor feeder or single feeder distributor. Fault occurs. So if there is a fault occurring at the distributor, all the consumers connected to that distributor will be affected. That means if we want to switch off that particular distributor for maintenance or for some purpose, all the consumers connected to that distributor will be having a setting. So I think all of you have seen in a particular day, if there is maintenance is there, the total area has to be shut down for maintenance or for repair work. So that means it is a distributed network. Sorry, it is a radial distribution. Okay. And in India, 99% of the distribution is radial distribution because we are expanding. So we are not, as I have told, we are not thinking about till now in India, we are not thinking about the quality of electrical power, but we are going the quantity we are only concentrating on. So now your Prime Minister says that electricity for all the villages. Till now, many villages are there where the power supply has not yet reached. Okay. Once you have that reached, then only we will think about improving that to improve the quality. So what we have done, let us say, initially only the supply was connected to Bhubaneswar. Okay. So next, as the Bhubaneswar is expanding, it will get a connection. Let us say now the new side is Sundarpada side is coming up. So there will be a connection from Bhubaneswar to Sundarpada. Okay. Then slowly Sundarpada area is going to develop, and beyond that there will be another area which has come up or which is included in the city. So what will happen? from the Sundarpada station only we are going to distribute the power to the next village or next area. Okay, so it is a radial distribution from Bhubaneswar to Sundarpada, from Sundarpada to that new area. So what will happen if there is some disturbance at the Bhubaneswar grid, then the rest of the areas will automatically be affected. So that is the meaning that if fault occurs either on the feeder or the distributor, all the consumers connected to that particular distributor will be affected. Now, as you can see, what are the advantage and disadvantage? Its initial cost is minimum because as we are not able to we don't know that where it will expand. Bhubaneswar may expand to the Cuttack side. It may also expand to the Puri side. It may expand up to Khordha side. So sometimes it is not feasible or it is not possible to predict the future. Okay, so to keep the minimum cost minimum, initial cost minimum, we only think about the current situation. So we whatever is the minimum requirement that we'll do by just connecting one feeder to that particular area. Simple planning and design and operation, as I've told, we are the only you don't need to think about multi-feeder system or which are the area to be covered. We only connect directly the feeder from one area to another area, and slowly we go on increasing in that particular direction. Useful when generator is at low voltage. Now, the main disadvantage of that is, let us say the distance is high. So now, as I have told, you have gone from Bhubaneswar to Sundarpada, the next village. So if the distance go on increasing, what will happen? Let us say Bhubaneswar, I am just talking about a voltage. Let us say Bhubaneswar, it is 11 kV. When it is going to Sundarpada, which is around 5 or 10 kilometers, it may drop down to 11.8 or 11.5 kV. Okay. Next village, there will be another drop. So it may come up to 11.2 kV. So in this way, when you are moving one direction, the loads which are connected at a far end, or as you go on increasing the distance from the original one, the voltage drop increases. Okay. So this type of generally connection is done when there is a low voltage. So you can do that in a particular small area. Let us say you have gone for Ghatikya area or you have gone for unit any particular area in the Bhubaneswar, then that can be done because it is not going to expand. How much the Ghatikya area will expand? It can expand up to a certain limit. Okay. So in those cases where the low voltage, we are only going for 11 kV or 400 kV lines, generally this type of system is used. Station is located at the center of the load, as that figure is done. If the station is not at the center and it is only at one end, what will happen? The one feeder will get higher voltage, the other feeder will have lesser voltage because the distance from the substation to that feeder is very large compared to the other side. So the let us say the substation is nearer to this side, so this side voltage will be somehow less due to the transmission line voltage drop. Distribution nearer to the feeding end will be heavily loaded. Now, what is the meaning of that? Now think of this situation, or let us say think of this situation. Okay, so this is the feeder system. So let us say this is having 1 kilowatt load. This is having 2 kilowatt load. So the load on this particular distributor will be 3 kilowatt. And like that, let us say this is another 5 kilowatt. So 3 kilowatt and 5 kilowatt. So the load on this side will be 8 kilowatt. Okay. So it is saying that distributor nearer to the feeding end, as you go on, let us say this is the end of the terminal. So as you go on towards the feeding terminal, the load on the distributor is going to increase because you are going to increase in one direction. So let us say you have gone to a village, from there to Sundarpada, whatever the load will be there, the conductor will only carry that current. From Sundarpada to Bhubaneswar, it will carry the current of demand of Sundarpada plus that village which is ahead of that one. So obviously when you are moving towards the feeding end, it is going to be heavily loaded. The consumers at the far end of the feeder will subject it to series voltage fluctuations with variation in load. Obviously, as I have told, so the voltage at Sundarpada, if it is at 11, that will be at 10.5 or 10.8. The next village will have 10.5, like that. As you go on increasing the distance, the voltage in the conductor is going to have a drop. So the voltage at the end terminal will be somehow less. So this is the main disadvantage of this one. So to get rid of that, the next system, which is a planned system. I think those who are staying in Raulkela, they have this ring road system. Okay, in Cuttack and Bhubaneswar, still now we are planning that there should be a ring road. Now, what is the advantage of ring road? You can see here. So now this cannot be done instantaneously. You need to have a very good planning, and some future prediction must be correct so that this will work. Okay. Now here you can see this is the substation, and then according to the loads we create a ring. Now this looks like a circle, but in practical may not be a ring structure. It is a closed path. Okay. So instead of having a single line feeder, what we have a ring like structure feeder. So what is the advantage of that? And from the ring-like structure feeder, then we have the distributors are taken. Okay. So if you want to go to from, let us say, point in the, I am talking about a practical case in ring road system. What is the, if you are going to from A to C, you can go from by B. If there is due to some disturbance, or there is some maintenance, or there is some cyclone effect is there, due to that there is a breakdown here. So this path is blocked. So still we have a path that it can reach the point A through this point AEDC. That is the advantage of this one. In the radial system, that is not, as I have told. If there is a maintenance or failure on this side, all the rest of the line ahead of that will have we are going to subject it to the supply failure. Okay. But here the advantage is, if there is a failure, let us say at point P there is a failure. So the B point may not be getting power from this one if it is a radial one. But in a ring one, you can have the supply somehow. Maybe you may ask that when you are creating a ring structure, we created to get these feeders to carry heavy amount of load, so that if required, it can contain the power. You can transfer the power from the other side. So the B point will get the power in the other side of this one, even if this line is shut down due to maintenance or due to some purpose, it is shut down, still the B point will get the power. So that is the advantage of having a ring system. Okay. And another advantage is, in a ring system we don't have that much of voltage drop. Let's say this is the substation. So from A, the current will flow from A, B and C, let us say. When you will solve the problems, you will see how the current will be distributed. Total current I flows from here. So I2 towards the left and I1 towards the right. So now what is the voltage drop here? Only I1 current flows this one. So drop will be somehow less. In the radial system, what was the current? The total current I was flowing through one line. So the point A was subjected to some higher voltage drop, point B, next higher voltage drop, point C, next higher voltage drop, like that it increases. But in radial, as the current is going to be distributed in both the paths, the current in a single feeder is somehow less. Okay. And as it is going to stabilize by a ring system, let us say there is a low voltage here. So the current will flow from the other side to stabilize it. Similarly, if there is a low voltage at the point P, because at that tapping, let us say the load demand has increased suddenly. In a particular area, there is a development and load demand increases suddenly. So what will happen? At point B, there will be heavy loss of or demand of current. So it has got two paths. Some part of that current will be made through A, some part of that current will be made through EDC, so that there will be no much voltage drop only in this line. It will be equally distributed in all the feeders. Okay. So less conductor material is required, as you can see, as I have told. Now this is possible only when you have very good planning. Okay. Otherwise, without that planning, we are not able to achieve this type of ring distribution system. Less conductor material used, as each part of the ring carries less current than in the radial system, less voltage fluctuation, and as I've told, it is difficult to design when compared to radial system. In radial system, you don't need to have a planning. As the demand increases in one direction, we go on adding the feeders in that particular direction. Okay, so we don't need to have a planning. But here we need to know which are the parts which need to be touched in a particular ring structure. Okay, then only those feeders will be taken from that point. Now coming to different types of DC distributors. Okay, we'll start with this one and then stop. Now DC distribution, when we will solve problems, these are the different types of problems we need to solve. So one is the concentrated load type problems, another is the distributed load type problems, and the third is the combination of concentrated loads and distributed loads. Now what do you mean by concentrated loads? Concentrated loads means we can show it by a single tapping. Okay. it is there, I can say. Here you can see that there is a load of, let us some certain kilowatt is connected here. So it can be shown by a single tapping. So the current from the feeder will be drawn for this one. Now this is the common feeder. AB is the common feeder and A dash B dash is the return path. I am talking about a single phase line, let us say, or a DC. There is two lines. There are two lines only. Now you can see load 1 is connected at this tapping A, load 2 is connected at this tapping B, and load 3 is connected at this tapping 3. So these loads will carry the current at this, or this current will be drawn only at the tapping C. Okay, so these are called concentrated loads. Now you can see the current distribution. So let us say you can see the feeder. The feeder BC will carry the current I3 only. What will be the current drawn by AB? It will be I2 plus I3. Okay, so current drawn in the section AB will be I2 plus I3. So that I2 goes to load 2 and I3 goes to load 3. What is the current in the section capital A and small a? It is sum of all the currents, I1 plus I2 plus I3. Okay, so now what is the, see the voltage effect of that one. So here the drop will be I1 plus I2 plus I3 whole into the impedance or the resistance of this line. Here the drop will be I2 plus I3 into resistance of this line. And similarly, where will be the drop here? I3 into. So as you move from the feeder end, what will happen? At what will be the voltage at C will be somehow less than B. What will be the voltage at B will be somehow less than A. So as you are, this is a practical case of your radial system. So as you are go on increasing towards the away from the feeder end, the voltage is going to decrease in your path. So the loads which are connected at the end of those terminals will be subjected to, here the load 3 will be subjected to minimum potential. Load 1 will be subjected to maximum potential. Okay, so those consumers will be here. Let us say you have tuned your transformer to have a voltage of intermediate value which is between load 1 and load 3. Okay, so let us say here to have that compensating the voltage, instead of 230 I have maintained a voltage of 240 here. Okay, so that this will be 235, this will be 230, like that. Due to the drop, I am just giving an example. But if by some means there is a disconnection here or there is a disconnection here, what will happen? The voltage on this side will suddenly increase, as you have learned in case of alternators. So if there is a decrease in load, then there is a sudden increase in the, if the decrease in the reactive power is there, then the voltage will increase. If there is a decrease in the active power is there, then a sudden boost will be in the frequency. So the point A, which was already at a higher potential of 240, now due to the shutdown of loads or the other two, the voltage may shoot to another higher value which may not be suitable for load 1. So that is the disadvantage of this type of system. Okay, so to get rid of that, we have another type. See here, concentrated loads. This is known as fed at one end. The example I have given you is the feeder which fed at one end. The other solution of that is feeding at both the ends. So when you are feeding at both the ends, then obviously this point C, maybe the diagram will be there. Here, as you can see, feeding at both the ends. So this is a common feeder where different loads are connected. There is a feeding point at B and there is a feeding point at A. Okay. Now, the same thing is now applicable to large cities. In Bhubaneswar, we have different types of feeding feeders from different areas, so that if one of the feeders goes wrong, then still we are able to get the supply. Okay. So here, what will happen? Now, in the previous case, what was taking place, the point C was subjected to minimum potential. Okay, now already there is a feeding point at B. So the potential of C will not be that much fall as in the previous case. There will be a higher voltage on this side. Which one will be the minimum potential point? Maybe at point B. Okay, so if you have feeding at both the ends, that voltage drop is somehow neglected from both sides. Generally, it will be somehow at the center, not at the end. And obviously that drop will be less. Okay, because now you can see, previously what was the current drawn here? I1 plus I2 plus I3. Now what is the current drawn here? I1 and some part of I2, not the total also, because I2 is at the center, part of that will be fed by the left hand side and part of that will be fed from the right hand side. So now what is the drop here? I1 plus some value of I2 into this resistance. What is the drop here? Only some value of I2, let us say X is that value. So X into R2 is the drop here. So you are also decreasing the voltage drop in the transmission line if you are feeding at both the ends. So each of these are having their own advantage and disadvantage. And now when you feed at both the ends, then we have two types of problems. Feeder at equal voltage and feeder at unequal voltage. Now you may ask, we should always go for equal voltage, but as I have told, those feeders will be connected from a grid or from a power system which is at far away. Okay, so let us say one feeder is connected from a system which is at 100 kilometer, the another feeder is there which is at 500 kilometer. So when the distance is not same, the voltage drop will not be same. So it is not possible to maintain equal voltage criteria always. Okay. So therefore, on most of the time, it is feeding at unequal voltages. So let us say you will get a voltage from NTPC or Talcher to Bhubaneswar at, let us say, 33 kV or 66 kV, and another from Sambalpur Hirakud power plant at 132 kV. Okay. So if you have that, then both of them will be acting as the feeders, but they will have different steps of stepping it down to low voltages. Okay. Then we have distributed loads. Distributed load means on the path, the total path is they are going to draw the current. Now concentrated loads can be shown as a single tapping. Distributed loads are generally mentioned like that, the 1 ampere per meter or 5 ampere per meter. Okay. So as the distance increases, the load is going to increase automatically. As I have told, in case of when we are calculating the RLC value or when we are calculating the voltage drop, what we have done, we have taken the value RLC value as the concentrated parameters. Okay. Now, when we take these to be concentrated parameters, our calculation becomes easy. Now, in long transmission line, we have not done that. In long transmission line, what we have done, we have concentrated that, let us say, total resistance of R value and is distributed over n kilometer length, then each section is considered as n R by n like that. Okay. Similarly, the inductance and capacitance part. So that will increase the calculations very much, but that is more accurate compared to these concentrated types. Okay. So generally, this type of loads, when you will solve problem, you will see that distribution, generally the loads are not concentrated type, they are also distributed type. And similarly distributed, fed at one end, fed at both ends, and equal only. All these, each section will have different problems on that and how to do the calculation. Okay, so next class we will start with the calculation part of this one. How to solve problems when it is at one end or at both ends, whether it is concentrated or distributed, or whether it is equal or unequal voltage fed at both ends. Okay, so next class we will start from this point. We can stop now. Anyone need to ask any question on this, you can ask, otherwise we can stop.